So you got positive correlation, negative correlation. We all go with that part? You guys got that? Positive, they're both working together, so they're both going to increase. Negative, they're working against each other. One's going to increase, one's going to decrease. Oops, I'm frozen. All right, no correlation. They are literally scattered everywhere. There's no relationship between the two sets of data. You can't do a line of fit or a trend line and no correlation because they're literally everywhere. Outlier. That is data points that are really far away from the other points. So like this information here, you can kind of tell if you draw your line of fit or your trend line, it kind of goes in the middle like that. And the closer the points are to that line of fit or that trend line, the better. Well, this one is way far away. So that would be your outlier. You could have one outlier, you could have more than one. Just depends. Good with that part? And the last thing is clustering. So it's kind of when your data points kind of group together. You can see if you get a clustering area, which I have right here. There's a lot of points together in a group. And that's pretty basic part of scatter plots that you guys probably already know from previous years. All right, let's go ahead and see if we can go further, see if we can figure out how to graph it, all that kind of stuff. All right, so I'm going to skip. I was going to review this, but I think you guys might be okay. I guess we'll see in a second. All right, so your next packet, you should have this packet as well. So a scatter plot is just a relationship between two variables, which we just talked about a minute ago. You can have a positive, you can have a negative, or you can have no correlation. Your positive is going to increase from left to right. Your negative is going to decrease. No correlation is kind of just going to be splattered all over the place. Your types of relationships can also be called your correlation. You may hear it like that. So positive correlation, negative correlation, no correlation. Remember, positive works together. So increase and increase. Negative works against each other. One increases, one decreases. And no relationship literally has no relationship. So when you're given a scatter plot, you're going to need to find your line of fit or your trend line. Those both mean the same thing. And that's kind of a line that goes through your data to tell you what's going on with that data. So that's what we're going to figure out how to do. We do have to refresh on what the equation is for a line, what's important about a line, how to graph a line. So hopefully we have that remembered in our head. Oh, I forgot to take attendance. Take attendance. I gotta get that down. All right. I'll go with this part. You got your, let's look at our lines of fit and our trend lines, kind of see what's going on there. Thank you for getting that. Here you go, girl. All right. So let's get further into this and see if we remember. So your line of best fit. You may just hear it called line of fit or trend line. All of those mean the same thing. So depending on if you're given a positive or negative correlation, it's possible to write a prediction equation. So it helps us make a prediction by writing an equation, and then we can kind of predict other information based off of that. Now this is where we need to refresh about a line. Does anyone remember the equation for a line? The equation for a line starts with y equals.
That helps somewhat.
Equation. Caden's looking on the walls. I'm trying to think of where it is.
Y equals
Yes.
A.
Nope, you're right over there. Slope-intercept form. The equation for a line is in slope-intercept form.
Oh.
I saw where you were looking, and I was like, oh, it's there. So slope-intercept form, since Caden found it, what is it? Mx plus b. So in order to do your line of fit, you have to have that in your memory, which we did earlier in the year. What are the two, who can remember, what are the two most important things about that equation? What are the two things you've got to know about that equation? Oh, Lord, help us. What are the two things you have to know about that equation? All right, I think we're going to have to stop and we're going to have to graph some stuff first. No one can tell me what the two things we got to remember about that equation?
Yeah.
The M, what's your M?
Your M and your B.
Okay, what's your M?
Your slope.
Yeah. What's your B?
Y-intercept.
Your y-intercept.
Actually, all that.
Okay. Oh, we'll see when we get to it. We still might have to refresh. So those are the things that you need to know in order to be able to do your line of fit for these scatter plots. Because then they're going to help us make a prediction. So for today, we're going to make our line of fits. And then tomorrow I'm going to teach you how the calculator will give it to you if you're given your data in a certain way. Today, we're just going to be given the graphs. So your calculator can't make it for you that way. If you're given the tables like we'll do tomorrow, your calculator can make that. All right, so let's look at our scatter plots. We're going to figure out what our correlation is. And then we're going to, did everyone get that? Did I jump the gun there? Everybody got that information? You good? Okay. All right, so let's look at our, all right, so the data in the group below shows the resting heart rates and age groups and ages of a group of 20 people at the gym. Which line best represents the data? Graph each line to justify your answer. First of all, if you look at this data, what type of correlation does it have? Does it have a positive, a negative, or none?
Negative.
A negative correlation because it decreases, right? So if it has a negative correlation, what type of slope is it going to have? A negative slope. A positive slope has a positive correlation. A negative slope has a negative correlation. So let's look at our options over here. Which one of those options have a negative slope? Remember, your slope is your M, right? So that has a negative M. That has a negative M. That has a negative M. They all have a negative slope, right? This last one, is that just y equals 50? Yeah. I don't see the x part, right?
No.
The reason being is because it was 0x plus 50. 0 times anything is what? 0. So that's why it just turned into y equals 50. So a 0 slope, no, it's an equal sign.
What about if it was a
I think it might have copied wrong on. Can you tell on yours that it's an equal sign? Yeah, I can tell on yours it is. In mine, it copied. So this one clearly does not have a negative slope.
Why would it be one?
Okay. What do you mean? Why wouldn't it be
Why
one?
would the x be one? Or d?
Oh, because if the x was 1, D's equation is just y equals 50, right? If the slope was 1, you would have to have 1x plus 50.
I thought it was-
You're missing this whole entire part. The only way you're going to miss that whole entire part, like the only way that part's going to go is if your slope is a 0. Because 0 times anything is 0, so it kind of disappears, you don't show it. If your slope is actually 1, you have to have it there. Okay?
I thought it was like this. I thought you said on like the x.
Like it doesn't matter if you have this. Like those two things are the same thing, whether you put a 1 there or you don't put a 1 there. But I don't even have an x in this, right? So it's not a 1 if I don't even have the x there. Okay? If I have the x there but no number, then it's a 1. All right, so I'm left with those 3. I got to figure out which one it actually is. Let's graph each one to see. How do I graph this equation? What's your slope? What's your y-intercept? And your y-intercept is, all right, so let's graph that one and let's see if my line of trend or my line of fit would be close to that. So if I put a dot at 80, what your slope, what does your slope mean? Down 2 over 3. So if I go, what is this counting by? Is this counting by 5s? 70, 75, 80, yes. And this is counting by 5s also. So each is counting by 5s. So if I go down 2, right 3, I'd be about right there. Down 2, right 3, somewhere there. That kind of looks like it's going in the right way. Possibly. You what? You think I can't hear you. You think it's B. Okay. This one might go over a little bit. So it's a little bit hard to do. You think it's B. Let's try B. So your slope is negative 1/3. And your y-intercept is 75. Okay. So put your y-intercept is 75. Go down 1 over 3. Down 1 over 3. Down 1 over 3. Yeah, it's looking like it's going to be that one a little more because that one would go a little bit more, whereas this one's going to be a little steeper. I'm going to go down a little further. The closer your points are to your line of fit, the better it's going to be. Okay. Try this one. Check C. Your slope on C is negative 1/3. Your y-intercept is 80. Go check that one. I don't know what I did with my. I don't know what I did with my stuff. Where did my pen go? All right, if you try C, what's happening with C? C again is the same y-intercept as that one, right? Negative 1/3 is not as steep as negative 2/3, right? So that's going to go a little bit higher. So that's going to go a little bit higher than that other one did. Which line is the best one there? That would be option B. That shows your data points closer to your line of fit. So there are times where you can eliminate at least half of them. There are times where you can only eliminate one, or you may not be able to eliminate any at all. But you need to know how to graph in order to be able to justify that. Okay. All right, let's try a couple more and see where. All right, look at this first one. What's that scatter plot doing? What's that scatter plot doing? What do we got going on there? It's what? What? What did you say, Marvel?
It's decreasing.
It's decreasing. So what kind of correlation does it have? A negative correlation. So what kind of slope is it going to have? A negative. So look at your options here. Which one of those options have a negative slope? All right, so I can cross off A and C. So those are automatically out of there. Now I have to check B and D. My slope on B is negative 3/5. My y-intercept is negative 2, right? So let's graph B to see if I make my line of fit, if it's going to be close to that. All right, so put a dot at negative 2. Looks like this one's all counting by 1. What does the negative 3 in your slope tell you to do?
Go down 3, 4, 5.
What does over mean? 1, 2, 3, 4, 5. There's 1. And then if I go up 1, 2, 3, left 1, 2, 3, 4, 5, and I make my line, is that a good line of trend?
Yeah.
Are my points close to that? It doesn't seem like they're very close to it. So let's check D. Look at option D. What's your slope?
Why are we going to type it?
Huh?
Why are we going to type it?
Because B is not good at all. Those points are not close to that line at all. That's not showing. Your line of trend should be going through your data. It's not going to connect all your points. That's not good at all. So your slope on D is negative 5/3. Your y-intercept is negative 2. So put a dot at negative 2. What does the negative 5 in your slope tell you to do?
Down 5.
So 1, 2, 3. Whoops, I can't, right? Down 5, right 3 would be kind of like right there. And then up 5, 1, 2, 3, 4, 5, left 1, 2, 3. So that is option D. Which one of those lines has your scattered plot points closer to it? D. So that is the better line of fit. Kaden, do you see now when we graph that one why B was not a good choice?
Beautiful.
Well, it isn't. If you picked it, you would have been wrong. So.
So I do everything at 10.
It's pretty smart.
Yeah.
All right. What type of correlation is that? Positive. So if it's a positive correlation, what type of slope should it have? Positive. So what options should I eliminate here? Very good, because they have a negative slope, right? So then let's check each one of these. What is my slope on A? And remember, you put it over 1. X is not part of your slope. It's the coefficient in front. And your y-intercept is 3. So let's go ahead and graph that. Start at your y-intercept. Start at 3. Put a dot. The 2 in the rise of your slope tells you to do what? Up 2, and then right 1. And then down 2, left 1, down 2, left 1. I can do that a couple more times. Down 2, left 1, down 2, left 1.
That is beautiful.
It looks to me like that's pretty good, huh? That's a lot better than that other one you were trying to say was perfect. I'm going to check B really quick just to make sure. So that's 1/2 and the y-intercept is 3. So let me just prove to us that it's, yeah, that's not good at all, huh?
Doesn't even make it this way.
Yeah. Clearly. So this one was D. So clearly B is the best choice. No, wait. That one was A. This one was B. It's not a good choice. That one was A. Okay. So chances are you're going to be able to eliminate at least 2. And then you can kind of work from there with your other 2. How many more we got on that one?
Did you do 3?
All right, jump. Sorry, I didn't mean to nail you with. All right, 3. Let's try 3, and then I'm gonna have you guys try a couple.
Hey, 3?
I said 3.
Oh.
Did you think I said free?
Yeah.
Oh, no. All right, look at 3. What kind of correlation you got going on there? Positive. So are there any negative slopes there that you could eliminate?
Yes.
Right, these 2? So eliminate. Look at A and C. Are they written in slope-intercept form?
No.
What are you missing? They are, but you're missing something from them, right?
See, you're missing the B.
In C, you said you're missing the B part. If you're missing it, what is the B part? What's your y-intercept?
1.
Well, 1. If it was 1, honey, you'd see it there.
Yeah.
If there's nothing there, then it is a 0. So your y-intercept is 0 for that one, and your slope is 1/4. So let's graph that one first.
Isn't that the same thing as A?
Huh? It is almost the same thing as A. I'm glad you asked that. What's your slope on A? 4, and to have a rise over run, you put it over 1. So the only thing that's different is it's switched, right? And your B value is 0. So they're kind of similar, but their slopes are different. So I'll graph A first. Let's start at your origin, start at 0. If I go up 4, right 1, and then down 4, left 1. Is that a good line of trend or line of fit or trend line? Thinking A is really awful, but let's check B. So B, the y-intercept is the same, but that one wants me to go up 1, right 4. And then down 1, left 4. Is that a little bit better line of trend?
Yeah.
Yes. Hi. All right, y'all try 4, 5, and 6. Oh, try 4 and 5. I think 6 might stump you a little. Huh? Look at. You could try 6 if you want, but I have a feeling it's going to stump you a little. Anyone know what form number 6 is in? See all your options on number 6? They look different, right? They're not in slope intercept, right? Anybody remember what form that is?
Standard form?
Yeah. That is standard form. I'm going to help you cheat on that one and use calculator. Okay.
I want to know about that both of them.
So they just started putting it on your tests, like on your Algebra 1 tests. They have it embedded. And I think they might have it embedded on the SC Ready as well now. So teachers are having to use it more. So it's not like we were like hiding it from you. It's just you weren't allowed to use it. Now you are, so
Basically.
it's not really a cheat, but there's no reason you shouldn't be able to use it. Like, you're in the grocery store, or if you're doing math anywhere, you're gonna pull your phone out and do, like, right? You're not gonna sit there with a pen and paper. So they just want you to be smart about it. All right. So what options on number 4 should I eliminate and why? What 2 options on 4 should you eliminate? Oh,
Hey, just that.
why A?
It's positive.
I can't eliminate 2 on this one, right? So negative correlation's got to have a negative slope. Actually, I can eliminate some others, right? Look at this scatter plot. Where does this scatter plot cross the y-axis? Doesn't this dot cross the y-axis right here?
Yeah.
What value is that? So the y-intercept has to be what?
It's B.
So it's got to be this y-intercept is negative, this y-intercept is negative. None of them are down here at all, right? So process of elimination and just common knowledge, I could eliminate 3 right away pretty much. Okay. All right, what about on B? What should I, is there any I can eliminate on B right away? A and B, oh yeah, because it's a negative correlation, so it should have a negative slope. I'm gonna check C. So C, my slope is negative 3/4, my y-intercept is negative 1. So let's see, negative 3 means I go down 3. Positive 4 means I go right 4. That seems like it's pretty spot on, huh?
C.
And then up 3 and left 1, 2, 3, 4. So it looks to me like C might be it. I'm going to try D just to check and prove. The slope is negative 4/3. The y-intercept is negative 1. So if I put a dot at negative 1, the negative 4/3 means I go down 4, right 3, up 4, left 3. So that one's a little bit more off, right? So clearly C is our best option. All right. 6 is what? C? He thinks 6 is C? Let's check. So do y'all notice those are in standard form? Okay, so remember standard form. And we're going to have to start reviewing this soon because it's going to be on your end of course. Well, your final exam. Standard form is when X and Y are together on one side. Okay, so let's go ahead. You think it's C, Marwell? All right, let me get my graphing calculator here. All right, go to Desmos. I know, I didn't use the cheat. What's going on with me? All right, go to Desmos. I'm going to try A. So if I put A in, first of all, what kind of correlation does number 6 have? A positive. So the slope has to be positive. So I know it has to increase. So let's put in A. Well, if you look at A, that decreases, right? So A is out of there. B. Same thing with B. That's out of there, right? So A and B are gone. Marwell thinks it's C. So let's try C. 2x minus 3y equals 12. All right, this one crosses at -4. Does mine cross at -4? 1, 2, 3. It does. You might be right, Marwell. What are some other points from C? So I'm going to check. It doesn't give me the table when I'm. All right, so let's just check D. C kind of looks like it might be it, but let's check D. 3x. I'm going to put it in the same so I can kind of see what's going on here. All right, that does the same thing. All right, now I got to figure out here. So why do you think it's that one as opposed to that one, Marwell? Can you see any? If you draw your line of fit, let's see if I can find any other points. That's like 2.6 repeating. I think it's D. 2.6 repeating. I think it's D, Marwell. That's what I'm getting. 2.60 would be like right here. So that means D would look like this. That is line D. If you look at line C, I'm going to grab another color for C. If you look at line C, let me grab another point from line C. Line C crosses the y-intercept at, or the x-intercept at 1, 2, 3, 4, 5, 6. So line C looks like that. So which one's better there? D. And all I did there was look to see where it crossed. Because it's in standard form, you cannot get a table. So I just looked to see where it crossed the y, where it crossed the x to kind of figure out. Okay? All right. I'm not even going to, hold on. Let's figure out where. All right. Let me stop this video for them. And stop sharing. Stop.